Welcome back. I want to take a moment to catch up on what has already been done to this SX-64 and what's coming up in this episode. Episode 1 was an introduction to the project, and I took the case off and took a look around the major components inside. In Episode 2, I removed the connector board and did the user port fix, separating two pins that should not have been connected in the first place. That was a manufacturing error with the potential to cause serious damage to the computer if somebody plugged a modem or other device into the user port. I also cleaned the power board and applied new thermal compound. In this episode, I'm going to turn my attention to the disk drive. I'm going to remove the storage bay, then the drive itself. I'm going to clean the heads, lube the rails, and replace the belt. I'll also take a look at the drive board and make note of a couple of interesting things there. Let's start with the drive board. You'll see that I've left the power unit off. I took that off in the last episode, and I'm going to leave it off for a while just to make it easier to access and to see some of the other components. So this is the drive board, and it's basically the same as what's in a typical 1541, except that the layout has been changed to fit in the SX's case. All the chips are the same, and you can swap them with ones from a standalone 1541 if you need to. There's a couple of interesting things here. If you remember from the first episode, I noted that the kernel ROM chip had a raised label on it. I thought that was kind of odd. Well, this chip is one of the DOS ROMs, and it also has that raised label. And since I can see this one better, it's apparent that this one is actually an EEPROM, not an original chip. Here's a similar EEPROM, and you can see the chip itself inside this little window. If you aren't familiar with the terms, ROM is read-only memory. It usually stores routines that the computer needs to operate, but that the manufacturer doesn't want the user to be able to accidentally mess with. An EEPROM is an erasable, programmable, read-only memory chip. It can be written to, erased by intense UV light through the window, and rewritten. Someone could buy a blank EEPROM, copy the code from the original ROM onto the EEPROM, and essentially have a perfect copy. Nowadays, we do this quite often when ROM chips fail. All the ROMs have been dumped or copied and can be found on the internet. You can buy an EEPROM programmer, sometimes called a burner, for $50, $60, or considerably cheaper if you're willing to wait for shipping from China. These days, most burners are designed to work with PCs, but there were EEPROM programmers for Commodores in the 80s. So someone has clearly made an EEPROM copy of these two ROMs and replaced the originals. Now, there are two reasons why someone might do that. First, if the original fails and a replacement is either not available or too expensive. Or second, if a newer version of the ROM is released and the user wants to upgrade. Now, sometimes there's a bug in the original ROM and the updated version has that fixed. Other times, it's simply a question of performance improvements, or, in some cases, new features. For instance, the 1540 drive, which was originally designed for use with the VIC-20, wouldn't work with the 64 because the 64's larger screen messed with the CPU timing and thus with the rate at which data could be transferred and read from the drive. If you wanted to use a 1540 with a C64, you actually had to blank the 64's screen while it accessed the drive. So Commodore released an updated DOS ROM for the 1540 that slowed the drive down so that it would work with the 64. A 1541 is essentially just a 1540 with that DOS ROM upgrade. There are a number of other ROM enhancements available today, from drive enhancers like Jiffy DOS to entirely new operating systems like GEOS, which can be burned onto an EEPROM for the Commodore 128. Now, given the quality of this label, it's not just a piece of electrical tape and a handwritten sticker, it was probably done by a dealer or a repair shop. Now, the date code on this one is 8328, indicating the 28th week of 1983. So that's when the EEPROM itself was made, not when it was burned with the DOS ROM or when it was installed. But since this SX-64 was manufactured in March of 1984, it's possible that this might have been installed by a dealer at the time that the unit was sold, if the updated version of the ROM was released after the unit was shipped. And this is the most recent version of this ROM. The other thing I thought was interesting about this board is that nearly all the chips are socketed. That's also the case with the CPU board, and the CIAs are socketed on the I/O board. Now, this was almost certainly done to make repairs easier if the chips overheated and died. The SX was designed to be portable, and it did have a metal case with little space for air circulation and an integrated CRT. It's also very possible that this unit might be used in situations that were hotter than a typical room in a house. And some of these chips had overheating issues anyway, so it wouldn't be hard to imagine that there might be a lot of failures due to overheating. Putting chips in sockets makes the repair process a lot easier and faster. I mentioned in the first video in this series that the drive unit itself can be replaced with one from an Alps model 1541, but the wiring harnesses are a bit different. I'll show you more about this later, but this is where they connect to the drive board. Alright, so first I'm going to disconnect the wires that connect the drive to the drive board. So this bundle here and then the head wires. Now this bundle here, if my hands are in the way, does not want to come off of there. There we go. And then it has to be fed, the bundle has to be fed through this plastic retainer here, which you can actually just lift this up, get them right out. And then in this case, there's also, lift this up and see if I can show you here. There's another plastic clip down here. And so we just have to push that through from this side. Really have no idea how well you were able to see that. And the easiest way is just to pinch these together from this side. Pop it through. And then before you go ripping it off, pull off the drive head wires. Alright, and there's one more clip down here, this black one. Trying not to get into my own light here. Okay, and that just bends up. Stick my fingers in here. And see, that just bent up. It just kind of folds over and then bends back up. Alright, so now our wires are free of the case. Okay, now before I remove the drive, I'm actually going to go ahead and remove the drive board. It's not necessary for this, but I need to have it out of there for later anyway, so I'm just going to go ahead and do it. I'm also going to remove this bundle of wires here, not because I really need to right now, but because it'll make it easier to get the drive out. If I just unclip those for now. Alright, now to get the drive board out, once you've gotten all the wires disconnected, we've got to pull this one. This one actually goes, I think, to the control board, to the drive reset up there on the control board in the front. We just get this out the same way we got the other ones out. Right. Now, the only thing that holds these boards in, or at least this board, is you've got these three little plastic pins here, and then it just sits in this rail at the bottom. So if I remove these 3 pins, this will come right out. And they just pop right out. So what I can do here is I'm just going to push on it with my push stick. You can see it kind of popped out a little bit there. And then I'm going to take my chip puller, because it's got this little notch in it. And I'm just going to put it over there and pop that out the rest of the way. Okay. So you've got this little pin, and then you also have a little socket there that it snaps into. And if that's going to stay in the bracket, I'm going to leave it there because I don't want to lose it. So I'll pop out these other ones. These come out real easy, but that also means they're real easy to put a little too much force on and send them flying. So you do want to be kind of careful. Okay. All right. Our pins are kind of sticking through here. Or clips, rather. So I'm trying to be real careful here because I don't want to break these. So I'm just kind of pushing them through. Okay. And there's our drive board. All right, now the drive and the storage bay come in and out as one unit. It's held in place by 4 screws, 2 on each side. Take those out and the whole drive and storage bay assembly will lift right up and out. Now you want to kind of lift from the back or kind of slide it back up and out. And you just want to make sure we miss our expansion port card there. Let me tilt it back and it lifts up and out. Okay, so here's the unit. I'm going to remove the storage bay and the mounting brackets, and they're just held on by these screws here on the side. Right up and off. Put that off to the side. Now, if you're interested, I have another video that I did a while back on a drive repair from an SX-64, in which I actually had to remove this motor. This is the spindle motor. This is what actually makes the disc spin. So if you're interested in that, I'll put a link to that in the description below as well. Okay, so this is the unit that I just removed from the SX-64, and this is a unit from a VIC 1541, one of the old versions. It's what I happen to have handy. But you can see it's the same mechanism. I got the same latches and everything. Okay. Now, the only difference is, if you'll notice on the SX, we have just the one bundle of wires that carry the signals to the motors and the circuitry that's on the board, and then we have the one bundle for the head wires. On the standalone 1541, we've got the bundle for the head wires, and then we've got 3 for the other wires. Okay. Now, I really don't know why Commodore did it this way, because this is the same 15-pin connector that's on the SX. And there's plenty of space, right? There are 15 wires on both of these units. So why the 1541 board wasn't just designed to run with one connector, I really don't know. That would be a good question to ask whoever designed the 1541's board, and I have absolutely no idea who that was. But if you ever needed to swap out the drive from a SX-64, you can replace it with an Alps mechanism from a standalone 1541. All you have to do is take the wires out of these other two connectors and put them in the right place on the 15-pin connector, and it should work just fine. Now, when I have the units out like this, I generally clean the entire thing as much as I can so that no dirt or dust gets back on the head after I clean it. I usually start with some compressed air and then a Q-tip and some isopropyl alcohol. This part doesn't have to be perfect. You just want to remove any loose contaminants. Frankly, this looks really pretty clean anyway, so I think I'm going to call that good enough. Now, next I'm going to clean the read-write head. The 1541 has only one. Let me tilt this up here so you can see. You see that little white square in there. The part that does the reading and the writing is actually the little black bit in the middle of the white square. One thing you'll notice is it's on the bottom, which means that when you insert a disc, you think that this is the way up, but it's actually reading and writing on the opposite side, on the bottom side. Now, cleaning the head is pretty easy, especially when the unit is out like this. You just take a Q-tip, dip it in some isopropyl alcohol, lift this up really gently. You don't want to damage the springs in there. And then you just want to kind of clean this area, rub it really gently. And check and see if your Q-tip's dirty. This one's actually pretty clean. I'm going to hit it one more time just to be on the safe side. And again, you're just really gently removing any dirt or grime that might be on the head. And when the Q-tip comes away clean, you're usually in pretty good shape. Sometimes you get some grime on there that just will not come off, and then you've got to be a little more, you have to take another approach to get that off if the isopropyl alcohol won't get it off. But I have not personally had one that's been that bad that a couple of Q-tips wouldn't, in alcohol wouldn't clean it off. Okay, now the head, you can move this little wheel here, make the head move. I don't like to just grab onto the head and move the head itself because that's plastic and it's kind of fragile, so when I have to move it, I use this wheel. But you can see that the head actually rides on two metal rails, one on each side here. Okay. Yeah, see that one in there. All right, so we want to take a look at those and see if those look particularly dirty, see if they've got anything that looks like, you know, permanent, or not permanent, but like really, really dirty, really sticky, anything like that on there. If you see anything like that, you want to make sure to get rid of that. Now I'm going to, again, Q-tip and isopropyl alcohol, and I'm just going to try to clean the rails here a little bit. as much as I can. You can't really get into them completely, but you can see that's kind of dirty. I want to get those cleaned off best we can. Move the head a little bit so you can get to as much of those rails as possible. Now, if you get stuff on there that's just really hard to get off, you might need to go to something a little more aggressive than isopropyl alcohol, like WD-40, which is a solvent. But if you do that, you have to be super, super careful not to get it on any of the electronics or anything like that, because it will screw it up. So the couple times that I've done that, I've just sprayed it on the end of a Q-tip, and then I've gone in there with the Q-tip and got it off and then hit it with isopropyl alcohol. But I hear about people spraying those rails with WD-40 and it just cringeworthy. You don't want to do that. Okay. Now that I've cleaned the rails, we need to actually lube them again so that the head will slide smoothly on it. Now, this is what I use to lubricate them, called liquid bearings. This is actually an oil that is designed for electronics. Okay, so it's not a solvent or anything like that. It's just an oil that is designed to be used on electronics. So just a couple drops on here is enough, and I usually put some on the front of the rail, and then I'll slide the head up. Put some kind of in the back here. And then just using this wheel, I'll just move the head forward and back a few times to get it spread around. And that's all there is to it. Now there's one more thing left to do. The spindle motor here that spins the disc, if we flip this over, actually push that down. Okay. The spindle motor has a pulley on the end of it that is attached to the actual spindle that spins the disc by this belt. Right. Now over time, this belt can get stretched out and worn. And if it gets too stretched out and worn, then the drive either won't spin as fast as it should, or it might spin erratically. Okay. It might spin at an uneven rate, both of which could cause problems with reading and writing. So I'm going to replace it. Now this is a new belt that I got from a store called console5.com. I'll put a link to that in the description below as well. And to change this belt is a pretty easy procedure. Okay, you just pull this one off. Okay, and if we lay them next to each other, you can see the difference in size. You can tell the old one is really quite a bit stretched out. Okay, you can see it looks like it's even got a couple of kinks in there where it's been sitting so long. So that one's going to go away and get replaced. And to replace this is pretty easy. You just hook it around the pulley, and then you come up here and lay it down around on the wheel. You just want to make sure that it is sitting evenly on the wheel, that it's not higher in one spot than in another. Okay. Because this big wheel, I'll show you that in just a second here. You can see here on the big wheel, this is just flat. Sorry. This is just flat. There's no grooves or anything for the belt to ride in. So you just need to make sure that it's sitting on there pretty evenly all the way around. And that's all there is to it. Okay. So as I've been doing, I'm going to leave this out of the case for now. And when I swap out the monitor for the LCD screen, I'll have to replace that control board there in the front that's just to the right of where the disk drive goes in. So I'd have to have this out anyway. So I'm just going to leave it out. I think I am going to screw it back on to the brackets and the storage bay just to kind of keep everything together. But the unit itself is going to stay out of the case for now. Okay. So that's it for today. Next time I have some work to do on the I/O board and the CPU board. And then after that, it should be time to tackle the monitor replacement. And if you're wondering, the main reason that I've been putting that off is simply because the LCD screen isn't here yet. So, waiting on the post office. It's not just to build dramatic tension or anything. So, as usual, feel free to leave comments below, and I will see you next time.